Welcome to 5-5 factoring trinomials. So this is the section that you're going to turn to in your notes when you have a trinomial. Remember, trinomial means three terms. A three-term polynomial. So they're going to look something of the form x squared plus a number x plus another number, or they might have a number in front of the x squared. They might have remember, A, B, and C stand for numbers. So there's a different way to factor these trinomials. One way is grouping. You're going to learn how to do regular factoring on trinomials and how to factor perfect square trinomials. So to start off, let's talk about those perfect square trinomials and what that means. What it means to be a perfect square trinomial is, first of all, it's got to be a trinomial. And the first term and the last term need to be perfect squares. For instance, the first term that's being squared, the first thing that's being squared is x, and the last thing that's being squared is the number 2, right? 2 squared would get you 4. Okay, so a perfect square trinomial is going to turn a trinomial, 3 terms, into a perfect square. So it's going to be one parentheses, and that parentheses is going to be squared. So what you do is you fill in the first term being squared, x, and the last term being squared, 2. Now, the middle term is important. This isn't a perfect square unless the middle term can be found by taking your u times your v times 2. So for instance here, if I took my ux times my v2 and times the number 2, what would I get? I'd get 4x. Does that match? Yes, it does. So what sign do I fill in? Well, it's always going to match our very first sign. Okay, so in this case, this first sign was a negative, so this needs to be a negative in here. Okay, sometimes it's hard to recognize perfect square trinomials, but I always like to look at my first and my last, make sure first of all, are these things being squared? Yes, they are. The first thing being squared is the number 4 and the letter y. Second thing being squared is the number 3. But it's not a perfect square trinomial unless this middle term can be found by taking 2 times u times v. Well, if I took 2 times my u, in this case it's 4y, times my v, in this case it's 3, what would I get? Well, 2 times 4 is 8, times 3 is 24, times a y, and they do match. So this is a perfect square trinomial, so it can be factored into one parenthesis that's being squared. I put a plus sign in my parentheses because it's a plus sign in my trinomial. And what goes into my parentheses is my u and my v. So my 4y goes in the front and my 3 goes in the back. Now how can I tell if this is correct? Well, you can always check your work. 4y plus 3 squared means 4y plus 3 times 4y plus 3. Would I get back to this original trinomial if I FOILed? Well, hopefully, if I did it right, I should. And it looks like I most certainly would after I combine like terms. So go ahead and see if you can try the last perfect square trinomial. Okay, hopefully you got 3x minus 5y quantity squared. How did I get that? Well, my first thing being squared is a 3x to get you 9x squared. The last thing being squared is a 5y to get you 25y squared. Now, I have to check to be sure that this is a perfect square trinomial. It's not always going to be. So I need to check the 2 times u times v. Check to see if it's that middle term here. 2 times u times v would be 2 times 3x times 5y, which would give me 30xy, and they do match. Now, because it's a negative, I need to put a negative in my parentheses. Sometimes you might have to factor out a common monomial factor before you can do anything. So I should have been, in all 3 of these examples, I should have been looking to see if I could take anything out of all 3. I can't take out an x, and I can't take out a 4. There's no 4 here, and there's no x here, so I can't factor out anything in the first one. Second one, I can't factor out a y. It's not in all 3. I can't factor out the number 3 because it doesn't go into 16. I can't factor out the number 2 because it doesn't go into 9. And there's no other numbers that fit in all 3 of these, so I'm good there. I can't factor out an x, I can't factor out a y, I can't factor out a 9, I can't factor out a 5 or a 3. So there's no numbers and no letters that go in all 3 of these, so nothing I could originally pull out. But here, in this case, in this trinomial, the number 3 can be taken out of all 3 of these. When I pull that number 3 out, what is left? Well, I'm left with an x squared minus 10x and a plus 25. So now that I've factored out a common monomial factor, I want to see if I can factor inside my parentheses any further. It's a trinomial, and so far we've only talked about perfect square trinomials. So I want to check and see, yes, the first and the back are 2 things being squared, right? My first thing being squared is x, my second thing, or my back thing being squared is a 5. So I want to check to see if the middle term does make this a perfect square trinomial. So the 2u times v would be 2 times x times 5, which is 10x, and they do match. So I know it's a perfect square trinomial. Well, I still have that 3 out in front. Now this parentheses is going to turn in to its factored state, where I fill in the u, and I fill in the v, and I can put the sign that's with my middle term negative. And that's as far as I can factor it down to. I'm not going to distribute that 3 back in. I'm not going to square this. I want to shorten it up as factored as possible. There's no sense in putting the 3 back in when we've just taken it out. Over here, what could I take out of all 3 in this trinomial? I hope you recognize that 4 is a number that you could take out, and there's actually a y and everything, so you could take out of this 4y, and that would leave you with a 4y squared plus 20y plus 25. Okay, so now I want to look and see in my parenthesis, is this a perfect square trinomial? So I'm going to check. The first and the last term, are they squares? Well, if I squared the number 2 and the letter y, I'd get 4y squared. And if I squared the number 5, I'd get 25. Now I need to check my middle term to see if it's the same as 2 times the u times the v. If I do that, I get 20y, so we match. It's a perfect square trinomial, so that's going to be 1 parenthesis squared. I have my 4y out in front. It's going to be a plus sign in my parentheses, and I fill in with my u and my v. Okay, other types of trinomials other than perfect square, regular trinomials, and how do I factor them? Well, notice this isn't a perfect square. Okay, look at the first and last terms. Yes, the first term, or the first thing being squared is x, and the last thing being squared is the number 2, but not really, right? I can't square 2 and get negative 4. 2 squared is 4, and negative 2 squared is still 4. So this isn't a perfect square trinomial when the back term is negative, okay? So it's impossible to put it in one parentheses squared. Even if you didn't recognize that negative, this middle term, it wouldn't be the same as 2 times x times 2, would it? It wouldn't be the 2 times u times v. So it's not a perfect square trinomial. So now, how do I factor it? Well, it's going to end up being 2 binomials, right? When you FOIL 2 binomials, you end up with a trinomial. So what goes in here? Well, when I take my first 2 in the acronym FOIL, it stands for first. When I take my first terms and multiply each other, it has to be x squared. So what times what would give you x squared? Well, that'd be x and x. So the first terms have to be x and x. Now the last terms are the tricky part. I need to find 2 numbers who, when I multiply them, I get negative 4. But when I add them together, it has to be this middle term, this 3. Okay, so I'm going to go over here and just kind of make a little chart of numbers that multiply to negative 4. So that would be 1 and negative 4, negative 1 and positive 4, and 2 and negative 2. There's no other factors of negative 4. So which grouping, which pair adds up to a positive 3, adds up to this middle term? And that would be this guy here. A negative 1 plus 4 is a 3. So those are my 2 numbers that I fill in. It doesn't matter which order they go. I could put the negative 1 here and the positive 4 here. It means the same as putting the positive 4 first and the negative 1 second. And if you're unsure if this is correct, you can always FOIL to check your answer. So you'd get x times x. X times 2 would be 2x. Negative 1 times x would be negative x. Ooh, why did I write 2 there? It was negative 1 and 4. X times x would be x squared. X times 4 would be 4x. Negative 1 times x would be negative x. And negative 1 times 4 would be 4. And when you combine these like terms, you get 3x for your middle term. And voila, my answer is correct because I got back to the, darn it, negative 4. Negative 1 times positive 4 is negative 4. I got back to the original trinomial. So factored form would look like this, 2 binomials. Okay, let's try some more. And hopefully I don't mess up this time. It's not a perfect square trinomial because there is no number when I square it I get 8. So I have to factor into 2 binomials. And I need to think what 2 numbers are going to multiply to give me negative 8. Negative 8. Well, if you come over here and look, they wrote out the factors of negative 8. 1, negative 8, negative 1, 8, positive 2, negative 4, and negative 2, positive 4. Now I need them to sum to be this middle term. So which pair adds up to be negative 2? And if I take a 2 and a negative 4, add them together, I get negative 2. So those are my 2 numbers that I fill in to my parentheses. Positive 2 and negative 4. Now remember, I need x squared as my first term, so I need an x times an x to be my first FOIL. Okay, the second one I'd like you to try. What 2 numbers are going to add up to 6, or sorry, multiply to 6 and add up to negative 5? So go ahead and find the answer for me. All right, hopefully you got x minus 2 and x minus 3 because If you fold this back out, the negative 2 times the negative 3 would get you positive 6, and you'd add together the negative 3x with the negative 2x, and you'd get a negative 5. All right, there's one more that is not a perfect square trinomial because 18 isn't a perfect square. So go ahead and factor this for me. So in this last example, if you think about the factors of negative 18, I listed them all out here. But which ones are going to add up to negative 17? And that'd be negative 18 and positive 1. So those are the numbers that go in your two binomials.